So we have arithmetic sequences and then we have geometric sequences. Our definition for a sequence is going to stay the same. So a sequence is still a list of numbers with a pattern. That stays the same. We have arithmetic sequences that are increasing or decreasing through addition and subtraction. We have patterns that have no, that we don't represent with an equation, okay, just patterns that we see. And then we have patterns that are called geometric patterns. And a geometric pattern increases or decreases by multiplication. So that is our big action with geometric sequences. Instead of finding a common difference, we're going to use multiplication. Now, whether the numbers are going up or down in the sequence, they are still multiplying. And I'll talk about that in a minute when I talk about our common ratio. So, instead of having a common difference, what we have is what's called a common ratio. And ratio means a fraction. Okay, so we're going to get our common ratio through a fraction. How we do it is we take our term 2 and we divide it by term 1. Always term 2 over term 1. And that gives us our common ratio. Okay, if the numbers in the sequence are going down or get smaller, then the common ratio is a decimal between 1 or -1, 0, and 1. So what this means is it means it's a decimal that is greater than -1 and less than 1. Okay? So if the sequence is going down, you're going to get a decimal that starts with a 0 in front of it. 0.1, 0.2, 0.3, whatever it may be, it's going to start with a 0. Okay? So that is our common ratio. Now we have our general form. Ooh, that's not how you spell general. Eraser. General form, also known as our explicit equation. And the general form or explicit equation for a geometric sequence is a sub n is equal to a sub 1 times the ratio to the n minus 1 power. Well, what do all these pieces mean? A sub n means the term at the spot n. Okay, same thing it meant before. A sub 1 means the first term, or the term at spot 1. N means the term spot, or not the term spot, just the spot. The spot we are looking for, the spot we are at, whichever one we're working with. And R is our common ratio. So that's what each of those pieces mean. Like I said, common ratio can increase or decrease depending on whether it's a decimal that starts with 0 or not. All the other pieces are the same as what we've seen before with arithmetic sequences. So let's do an example. An example that I have for you says 3, 6, 12, 24, 48, ... So first I'm going to find my common ratio. So I'm going to take term 2 and divide it by term 1. Well, term 2, if I number my terms, term 2 is 6. So I'm going to take 6 over term 1 is 3. 6 divided by 3 is 2. So that is my common ratio value. Next, I'm going to plug into my general form. So my general form says a sub n is equal to a sub 1 times the ratio to the n minus 1. I use lots of different symbols for times. The dot is one of them. The little asterisk or the little star is another. But I have my general form, okay? I'm going to plug in what I know. So I have my ratio equals 2. My a sub 1, or my first value, is equal to 3. I see that by being the first value here. So I'm going to plug those things in. A sub n is equal to 3 times 2 to the n minus 1. This right here is my general form, or my explicit equation for this sequence. So if I ever ask for the general form for a sequence, it needs to include the n's, but everything else needs to be replaced. So the n is what makes it generalized. What makes it for this sequence is by putting in the information that we do know. So now that I have my general form, I'm going to plug in to find, say that I want to find the, let's do the 10th term in the sequence. So I'm going to make n equal to 10 then, because I'm finding the 10th term in the sequence. And let's see if I can move this over a minute. Okay. So I'm going to plug in 10 wherever I see an n. So I have a sub 10 is equal to 3 times 2 to the 10 minus 1 power. So this whole thing is the exponent. I'm going to simplify 3 times 2 to the 9th power. In my calculator, I can take 2 to the 9th power. I'm going to use that caret key, so I'm going to click 2, and then I'm going to click the key that looks like an upside down V called the caret key, and then I'm going to click 9 in your calculator. And so I get 3 times 512. Holy cannoli, that's a big number. And then I'm going to multiply those, and I'm going to get 1536. So that is the value at the 10th term. So if I kept my list going to the 10th term, I would have 1,536. You will notice that values grow or shrink fast. Okay, and that's because we're multiplying, and multiplying happens bigger, faster, and makes numbers bigger or smaller quicker than addition and subtraction do. Okay, things grow quicker. So that is my a sub 10, or my 10th, the term at spot 10. Okay.